Howdy guys, I am back with section 8.5 from our textbook, which is kind of a nice section because really at the end of the day, it's mostly a review of things we've talked about before. It's called function classes. Let's dive on in. So one of the things, and we've been working towards this all year, that we want to be able to do is when we look at a graph, we want to be able to say what kind of function it is. Or when we look at an equation, we want to be able to say, okay, so that's a quadratic, it's going to be a parabola. We need to know kind of what that graph looks like. So we have 9 functions here that we're going to look at. And I'm going to kind of go through them one by one, talk about them a little bit, revisit their equations and just the key features of the graph. And then that'll be it for this section. So first one, nice one. Constant function. We've been talking about that for a while. What is a constant function? It's always just y equals some value. Y is constantly that value, which means it's a straight horizontal line. All lines are straight. It's a horizontal line. It just goes straight across. So the example here is y equals 1, and it just goes straight across. Horizontal, it's constantly that. Now, a second type, and we haven't really talked about this before, but a direct variation function. We talked about direct variation in section 8.4. It has the equation y equals kx. Well, that's almost like y equals mx plus b as long as b is 0. So direct variation functions always go straight through the origin, and they are always some diagonal. It's direct. They have a linear constant slope. This is y equals 2x, y equals kx through the origin, and a slope of 2. K is 2. So we've kind of talked about that. Now we're just calling it direct variation and putting the stipulation that for direct variation, it will go through the origin. All right. Identity function is a very special function, only one of its kind. And it's that y equals x. Slope of 1, y-intercept of 0 goes through the origin. That's our identity function. Now, before I continue on, because I said we have 9 of these, something to think about, is the identity function also direct variation? The answer is yeah. I mean, y equals kx, we could say this is y equals 1x, slope of 1. So the identity function, that could also be called direct variation, but we want to be as specific as possible when we're talking about these functions. And so this one, you know, to be specific, we should say it's the identity function, y equals 1x. All right, next 3. Everyone loves step functions. Greatest integer functions, often called step functions, look like stair steps. And how do we know this in the graph that it will be a stair step? It has this greatest integer operator. It's kind of that double bracket, greatest integer. You might remember that from a long time ago. But greatest integer basically means the greatest integer of x. So when we're at 0.5, we haven't quite made it to 1 yet. So the greatest integer we've made it to is still 0, all the way there. And then as soon as we hit 1, we're going to jump back up. But 1.1, 1.2, 1.7, 1.8, 1.9, all of those, the greatest integer we've hit is 1 until we hit 2, and then we jump up. So there's that stair-stepping function, greatest integer function. Kind of easy to tell just from the graph. Oh yeah, that's a step function. Then we go v for value. Absolute value always is in the shape of a v. Sometimes it's an upside down v, or a skinny v, or a super wide v, but it's always in the shape of a v. The equation always has absolute value bars. Y equals absolute value of x is here. Quadratics, we spent a ton of time looking at these. Quadratics, remember, x squareds. So always going to be either a smiley face or a frowny face, but quadratics, parabolas we've done a ton with, and it's always going to have some number of x squareds as the highest degree. Kind of written down here, y equals ax squared plus bx plus c. And let's talk about those last three then. Square root function, a little more recent, chapter 7 from our current book. Starts off steep, levels out. Maybe it starts going down steep and leveling out. It could go left, it could go right, but it has that very distinctive starting point, going steep and then leveling out. And then how do we know it's a square root function? Just from the equation? Well, it has a square root in it. That makes a lot of sense. A rational function, which is what we've looked at quite a bit in this chapter. I want to start with the graph. How do we know it's a rational function? It will have either, if you think back to 8.3, holes, vertical asymptotes, horizontal asymptotes, some combination of those. So here we can see we've got ourselves a vertical and a horizontal asymptote. And it has that very distinctive double swoosh sort of shape. Not many other graphs we've seen have that. This is a rational function. Looking at the equation, it's a function. Rational means including a fraction, can be expressed as a fraction. So x plus 1 over x minus 1, that is a rational function. And then the last one we're looking at here, very, very specific, kind of like the identity function, is the inverse variation function. Y equals some number over x. Okay, y equals some number over x. A over x is what it says down there. And what makes the inverse variation function special is that it will always have horizontal asymptote at y equals 0 and a vertical asymptote at x equals 0. It's so nicely positioned on our graph, kind of meeting those asymptotes, crossing and meeting at the origin. That is the inverse variation function. If you're asking yourself, wait, is inverse variation also a rational function? Yeah, it is. Kind of like the identity was also direct variation. It's just a more specific one. If the asymptotes are on the axis, if it's just a number over x, it is inverse variation. So talked through 9 graphs kind of quickly, but that's because we've spent all year kind of analyzing these and getting ready for this. When I say absolute value graph, you should see a V in your head, maybe an upside down V again, but a V. When I say a quadratic graph, you should see a parabola. And that's where we want to be. So other than that, I just want to do one graphing example. Identify and graph the following function. Well, I'm hoping you recognize it is a rational function, and specifically, it looks like inverse variation because it's a number over x. Y equals 4 over x. So either identifying from the graph or from the equation, we should be able to see exactly what kind of function it is. How do I graph a rational function? Well, quick review, since this is the chapter for it. I'm going to say, okay, there are no holes. There was nothing I could cancel. There is a vertical asymptote because we couldn't cancel that. So what would make it equal to 0? Well, if x equals 0. So I'm going to put a vertical asymptote right at x equals 0. Horizontal asymptote, if you remember, we look at the degrees on top and bottom. Degree on top is 0. There are no x's up there. Degree on bottom is 1. So greater on bottom means horizontal asymptote at y equals 0. And we kind of already knew that just from this being an inverse variation problem. We knew where those asymptotes would be. Now, to actually see generally what this graph looks like, let's plug in some values. If I plug in 1, we get 4 over 1, 4. If I plug in 2, we get 4 over 2, which is just 2. If I plug in 3, we get 4 over 3, so like 1.333, 1.3 repeating. It's a little over 1. And you should be able to see and anticipate, okay, so this side is going something like that. 0 I know is undefined. That's my vertical asymptote. What about -1? We get 4 over -1. So -4, -2, 4 over -2. I didn't quite leave myself enough room. -2. How about -3? We get roughly -1.3 repeating. And so again, you can start to see that swoosh shape showing up. And there's our graph. Inverse variation. So this is a pretty short section, a pretty short video, I know. Nothing wrong with that, right? Just looking at all the different graphs and types of functions we've seen throughout the year to this point, 9 of them, and being comfortable with seeing the equation, anticipating the graph, or seeing the graph and anticipating the equation, what kind of function family it is. But take a look at your practice problems. If you have questions, reach out to me or ask them during our next class, and I will see you next time.